Welcome to Professor Crain's Net Present Value lecture. In this lecture, you will receive a better understanding of the concepts concerning NPV, or Net Present Value. So let us get started. First, we should consider that our company is willing to invest the amount of $9,000 into developing a customer relationship management system, to ensure our competitive market strength. Before we begin, we believe our project has a life expectancy of 4 years before we may need to re-evaluate the software for updates. In addition, we trust that the software will generate additional business in the amounts of $2,000 in the first year. The second and third year we should sustain $3,000, and the fourth and final year, we can expect a return of $4,000. Now, to make more sense of this, let us move to a timeline to visualize the described cash flow. You can see, we have an internal investment of $9,000, thereby acquiring a sum of 0 or an illustration of the investment taking place today. The demonstrated cash outflow should be illustrated below the baseline and as a negative cash flow. At the end of the first year, we show cash inflow, a positive number of $2,000 above the line, and the $3,000 are shown for year 2 and prospectively for year 3, both are above the timeline in illustration of a positive number. At the end of our timeline, we'll have a cash inflow of $4,000. Now, in many cases, we have to borrow the necessary cash from the bank, which we will assume will be a return of 10%, this is known as our cost of capital. With this in mind, we are ready to configure what our net present value is for each consecutive year. In starting this sequence to determine the net present value, we add present values of all cash inflows, to the present value of cash outflows. The net result is the present value or NPV. To begin, we first use the formula of future value, which equals present value times 1 plus r, raised to the power of n. This can also be arranged to read future value divided by 1 plus r raised to the power of n. The future value in the formula of the specific cash flow are relevant to the cost of capital. In my example I am using 10%, or 0.10 in decimals, and n is relational to the time periods. By submission of the values are relevant to time periods, in doing just that, we find the answer to the first present value of the described cash flow. The process is repeated year over year, with the n illustrating the expected cash flow for each represented year, and so on and so forth. Finally, we find the last present value of the last cash inflow. The process of finding present values, based on future values, is also known as discounting. With that in mind, we have now completed the discounting for all future cash flows at 10%. So what is our next step? We will need to add up all the present values and determine the NPV, which totals to $283.51. Let me explain what our end results show. First, we have demonstrated a positive NPV, which means that the present value of all cash inflows exceeds the present value of cash outflows. We have exemplified this by the $283.51. This result expresses to the company and to us, a good investment, since it adds the amount of value to the company. Now, that was fun. Talk later, Professor Crain, and don't forget about dinner tonight.